final too. It's a lot of stuff that you guys know, but maybe you haven't done in a long time. Kind of doing applications of the derivative. No, yeah. I have to redo it.
Is it like during school or?
Let's finish this and we'll talk about it. I'll do whatever you guys want. I don't really care. But whatever is like easier.
Okay, I wouldn't know what we're learning today, let alone anything else.
Alright, so I rewrote your two rules just in case you kind of forgot them. So derivative of e to the x is e to the x, but when you guys have the derivative of more than something just up here, we have to figure out what du over dx is, right, as well as what du is. Okay. So the first application is writing the equation of a tangent line at a given point. So we did this a long time ago, right, back with like polynomials and all kinds of other stuff. So here's your equation, y equals e to negative 2x plus x squared at the point 2, 1. Okay. So the big thing we need to figure out is, well, what the heck do we need to write the equation of a tangent line? Anybody know? All right, we need a point, but how are you going to get the slope? Yeah, here, good job. The derivative. All right, you need to find the derivative. Okay, the derivative. Okay, the derivative will give you guys the slope at the point. Okay, so in order to write the equation of the line, right, going back, your equation of the line was this y minus y1 equals n, parentheses x minus x1, and you let the x1 and y1 come from the point that you're given. So we know a couple things about this. The plane y and the plane x stay the same, but you have to sub in. And when you guys are trying to do that, we're missing something. We don't know the slope. So to figure out what the slope is at that given point, what we need to do is first is to find the derivative at the x value. So step one is we need to get the derivative of this piece. Okay. So using your rule, right? We don't have just e to the x. We have e to a ton of stuff. So let's use this property right here. E to the u, du dx. All right, so let's see. What would you guys want u to be?
Negative 2x plus x squared.
Awesome.
So is this part what we did yesterday?
Yep, this part's what we did yesterday. Okay. So now if you guys wanted to do du, what's your derivative going to be?
Negative
2x. Good. What do we have to write here? Because you did it with respect to dx. Right. Notation. Well, you're going to go to notation too. All right. Really, really important because otherwise you don't know how to get du over dx if you don't know those things. So now to get du over dx, what would you guys have to do? Divide by dx. Good job. Awesome. Okay. All right. So now du over dx is this chunk. So when we go to figure out what the derivative of this actually is, right, we're going to use our property that e to the u, we're just going to write that out, e to the u, my u is just the top part, times the du over dx, which was this section. So times negative 2 plus 2x. Let me know if I lost anybody that part. If you want to like make this look nicer for yourself, I mean, by all means you can. If you would rather, I mean, you could do y prime equals, you want to bring this to the front, negative 2 plus 2x, and then e to the negative 2x plus x squared. Not really a big deal. The reason why you guys need that, though, is so you can figure out the n value. This is just going to give us the slope. But to get that slope, what we have to do is plug in the x coordinate. Okay. So your x coordinate that they gave you way back up top was a 2. So if we want to figure out what the slope is, we're using x in the derivative, we need to put 2 in its spot. There's a lot of like kind of math going on in here. When you guys simplify, this should give you guys a 2e up to the top. This is what you were talking about before, Kyle? Good. Alright, so we have 2e to the 0. What's e to the 0? Anybody know? 1. Good job. Oh, this is what you do. Yes, you know it. Yeah, so here we get m is going to be just 2. Right. Once you did all that work, now we can take the m, plug it back in up here. You know it's 2 now. And now we can actually get our equation. So y equals 2x minus 3. Do you guys remember kind of doing this? Just a little bit? Yeah. It was just, we didn't do it with e. So. What is the point of e?
What do you do with it? How would you apply that to
like exponential growth and decay when something's compounded continuously.
Right, but
if you want, okay, wait, I actually have, for once in my life, I think I have an application for you. Alright, so let's say you want to figure out, okay, if you had something that was compounded continuously, with bank account, you want to model a graph and figure out what was going on at one specific point. Like, let's say you graphed something, I don't know, how many continuously, this is what it looked like. And you wanted to figure out maybe like what was going on at that specific point. That would be like a application.
Do you feel uncomfortable with it?
Yeah, a lot. I haven't done that.
They cancel each other out.
There is like cool stuff. Like as application stuff, right?
A lot of graph stuff, just like figuring out.
2.7 something.
Oh no, it's 2.73, but what is it? No, like what's the variable e mean? It's just a given number.
It's like pi. Irrational.
What does it relate to though?
So like the biggest like basic application is something compounded continuously. Like E with RT. Like so if you left a bank, something in a bank account, it's compounded like every
pi, you know, is there a ratio to whatever something, you know, whatever that.
I don't know.
No.
Oh, yeah,
That's cool. That's like major stuff.
yeah. I don't know. Google it. I'm not sure, like, I know, like, where it's used, but I don't know, like, who came up with it, or, like, why. The biggest thing is kind of like pi. It's an irrational number that can be applied to, like, use pi for circumference. Anybody like that one? No, we're not going to do that. There's a land of Google that can explain it enough.
I've never used Google before in my life.
Why not?
Because you know how hard.
Don't even know what that is.
We have to think of something really good. But the other day is our big dress. We'll figure something out. Alright, we look like that today.
Alright, so implicit differentiation is another one we haven't done in a while. Okay, it's a little bit tougher with ease, I think. Right. Implicit differentiation is when you guys were taking the derivative with respect to x, but you had mixed stuff in here. So after you took the derivative with something with y, what did you have to write after? You had an dy dx. And we have to start by taking the derivative of both sides. Alright? You want to take the derivative of both sides. Okay. So when you guys start this, okay, part of this is pretty easy. Alright? If you let's leave this one out for a second. What's the derivative of 2x? Or sorry, 2x. And 2y.
dy.
Yeah, great. And then 0. Perfect. This part's super easy. We've been doing that for like ever. Now, in here though, things get a little bit more complicated. Right? Inside, yes. So you have to be very careful with this. And again, this is kind of stuff I would do this like on the side of your paper somewhere, right? What's your u? X, y, good. Now when you do du, what do you have to use? Product rule, yeah, good job. So product rule, 1 y plus x dy dx. Okay. Now this is like your book. If you like, this would come up in your book, but it's kind of tricky because you just did the product rule, right? What did you do it with respect to? X, right? So we have to write. This is where your dx is coming from. Now, because you're dealing with your e, right? We want to get e to the u du over dx. That's going to be my derivative. So we have my u. I got the du.
How do we know what we did it to respect to, X or Y?
It's going to be with respect to x, because the reason why you didn't do it with respect to y is because what did you have to write after a y?
That's why.
That's why.
Yeah.
All right. It's always with respect to x.
Yeah, did you distribute afterwards, like the x, y?
I don't think I distributed. Oh, yes, I did. Yep. Okay, so here we go. We'll divide by that. Okay. So now you guys kind of have everything you need for this just one little section, right? We're going to use our e to the u, which is x, y. We're going to times that whole thing, though. Up there. That whole thing's got to be multiplied by y plus x dy dx. I should make that bigger. Right. Are you guys okay with this part? Like, I didn't do the one times y. No. So this part right here is your du over dx. Now this is a beast after. When we are bringing this stuff all through. Okay. Carolyn, this is what you were talking about here, right? Is this it? What you were thinking? Yeah. All right. So we have to distribute that e through. So y e to the xy plus, I mean, it doesn't matter if you guys put the y before or after. Yeah, so for x dy dx e to the xy, right? And all this other stuff is gonna go. No. So like, Kyle, when you distribute this through, y times e to the xy is just this part. And when you distribute this one through, x times x.
The y goes in exponents? Is that?
These are not exponents, they're like regular,
How are you?
like you're multiplying e times y, if you put it that way.
Oh, okay. You're taking it from the exponents, so I thought you were multiplying the exponents on
Oh, no,
So
like the
that's-
bases.
Okay.
Right. Now, when you guys were solving for dy dx with this implicit differentiation, you needed to move everything to the other side besides the dy dx's. So just to save yourself some like trouble, how would you move this one over? Subtract it, yes. So make this one negative. Okay. This one's got to go over, so that one's going to be negative. Right. And with what's left, what could you factor out now?
dy dx.
dy dx. So take your dy dx out. Okay. And if you took it out of here, we'd have x e to the xy. If you took it out of here, we have minus 2y. Okay. So your last step to get the dy dx by itself is c division. Right. And then those would cancel. Right, and that's what you guys would have for your dy dx. Now, if someone moves things the other way, right, like you could have the same exact answer, but you would have just opposite signs for the whole thing. Right, it just matters like which things you moved. Right,
Like
they're
negative
equivalent.
2y plus x is
Like,
xy on the bottom.
yeah. Yeah. That'd be fine. All right. So your homework, guys, is on page.
Oh,
61, 65, and it's in 5 or 3.
X minus y and negative y. Oh, is that negative y?